Warfare has always evolved with technology, but today, artificial intelligence is rewriting the rules entirely. The world's militaries are racing to build not just bigger or faster machines, but smarter ones, where AI is the new battlefield advantage. Stealth fighters are now flying supercomputers, destroyers are networked brains at sea, and unmanned drones are learning in real time. This is more than an upgrade, it's a paradigm shift. AI brings speed, precision, and decision-making beyond human limits. Imagine fleets defending themselves autonomously, or pilots receiving perfect solutions before they even sense danger. The line between soldier and machine is blurring, and understanding this revolution is crucial for anyone interested in the future of conflict. Welcome to the new age of warfare, defined not by firepower, but by processing power. Military AI means machines that process vast data and make split-second decisions, faster than any human. On the battlefield, AI is the ultimate co-pilot and analyst, turning chaos into clarity. Its edge comes down to three things: speed, precision, and endurance. AI reacts in microseconds, outpacing human response and redefining defense in the age of hypersonic threats. It delivers surgical accuracy, guiding munitions, analyzing intelligence, and identifying threats with unmatched detail. Unlike humans, AI never tires. It can patrol, monitor, and analyze 24/7, maintaining vigilance over vast domains. This tireless, precise, and rapid capability transforms military operations, freeing humans for higher-level strategy. AI is not just a tool, it's a force multiplier, changing the very logic of war. In this series, we'll reveal how AI is transforming four pillars of military power. First, the sky's stealth fighters like the F-35 use AI as a digital co-pilot, fusing sensor data for unmatched situational awareness. Autonomous drones, loyal wingmen, are making machine dogfights a near-future reality. At sea, destroyers with AI-driven systems like Aegis track and intercept threats, coordinate with unmanned vessels, and optimize every move. Submarines use AI to analyze sonar, detect enemies, and deploy autonomous underwater vehicles for dangerous missions. Aircraft carriers rely on AI to manage flight operations, logistics, and defense against new threats like drone swarms. Across air, sea, and undersea, AI is the new nervous system, making platforms smarter, deadlier, and more resilient. This is the arsenal of the future, intelligent, networked, and always evolving. This series is for anyone fascinated by military history, technology, or the future of security. Our mission: cut through the hype and explain how AI is truly reshaping defense. Clear, accessible, and exciting. We'll connect the dots from past to present, showing how AI is revolutionizing everything from fighter jets to submarines. Expect well-researched, engaging content with stunning visuals and expert insights. We'll show you how AI creates jets that think, destroyers that anticipate, and submarines that hunt with intelligence. First up, the high-stakes world of aerial combat and the F-35's digital brain. Subscribe and join us as we explore the dawn of the intelligent battlefield. Welcome back. Today we take to the skies with the stealth fighter. Stealth is more than shape and materials. Modern jets like the F-35 are flying data centers, built for information dominance. The real revolution is digital AI-driven systems process sensor data, turning chaos into actionable intelligence. In the electromagnetic battle space, speed of information is survival. AI gives pilots a god's-eye view and instant solutions. These jets network with allies, analyze threats, and manage their own health, all in real time. The shift is from stealth fighter to information fighter, winning not just by being unseen, but by knowing and acting first. Next, we'll break down how AI powers this transformation, from pilot support to autonomous wingmen. The age of the intelligent aircraft has arrived. AI enables sensor fusion, integrating data for pilots. Older jets require pilots to scan multiple displays, mentally piecing together information, a demanding task. Sensor fusion acts as a digital co-pilot, creating a unified display. The result is a god's-eye view with threats identified and tracked. This reduces workload, freeing pilots for strategic decisions, enhancing battlefield awareness. AI is crucial for keeping complex machines like the F-35 in the air. Managing maintenance was a monumental task. Enter ALIS, now succeeded by Odin. This AI manages the F-35's global support network, monitoring the health of every aircraft in real time. Upon landing, data is downloaded. ALIS analyzes flight data, comparing it against the fleet's history, looking for anomalies. It flags parts for replacement and schedules maintenance. This AI-driven approach is a game-changer, increasing aircraft availability and safety, ensuring these assets are always ready for the fight. The complexity and cost of modern fighter jets mean pilots can't spend all their time training in real aircraft. Advanced AI-powered flight simulators have become an indispensable tool. They provide a training environment that can be even more demanding than reality. The AI generates complex, dynamic training environments with a vast array of potential threats. The AI acts as an intelligent instructor, monitoring the pilot's actions. After the session, it provides a detailed debrief, highlighting areas for improvement. These networked simulators allow pilots in different locations to train together. AI is not just training pilots to fly, it's training them to think and adapt. A game-changing application of AI in air combat is the development of autonomous combat drones, often called loyal wingmen. The concept is revolutionary. For every manned stealth fighter, there could be several AI-piloted drones flying alongside it. These drones are cheaper and more expendable than manned aircraft, allowing them to take on the riskiest roles. They act as an extension of the manned fighter, augmenting its sensors and carrying extra weapons. Programs like Australia's MQ-28 Ghostbat are making this a reality today. The pilot acts as a mission commander, giving high-level commands to their autonomous teammates. These AI-driven drones can be sent into the most heavily defended areas. This human-machine teaming represents a fundamental shift in air power. The AI enables these drones to operate with superhuman coordination and speed. The rise of the AI-piloted loyal wingman is set to completely rewrite the rules of air superiority. The classic image of air combat is the dogfight. However, the relentless advance of artificial intelligence is now challenging this long-held paradigm. AI is being developed that can master the incredibly complex art of the dogfight. This has been proven in simulations such as the Alpha dogfight trials conducted by DARPA. The AI defeated a human pilot decisively, winning every round. The AI's success stemmed from its ability to learn and its sheer speed of calculation. It suggests a future where the deadliest fighter in the sky might not have a person inside it. With AI co-pilots, autonomous wingmen, and AI dogfighting champions, what is the future role of the human fighter pilot? The role of the pilot is being redefined, evolving into a high-level mission commander. The focus is shifting from physical skill to cognitive skill. AI lacks the ethical reasoning and creative problem-solving abilities of a person. The pilot's job becomes more about directing AI systems and making critical command decisions. It's about building a symbiotic partnership between human and machine, where each plays to their strengths. This allows the human to operate at their highest potential, focusing on strategy, ethics, and creative adaptation. Welcome back. Today's guided missile destroyers are multi-mission warships. Packed with sensors, missiles, and cutting-edge technology, they combat threats in the air, on the surface, and beneath the waves. These ships are the sentinels of the fleet. AI is indispensable, connecting the ship's systems into a cohesive fighting unit. AI allows commanders a clear view of their environment, prioritizing threats. AI transforms destroyers into intelligent platforms, dominating the maritime domain. At the heart of a modern destroyer's defense is its combat system. The most famous is the Aegis combat system. Designed to defend against coordinated attacks, Aegis combines radars, computers, and missile launchers. Its secret ingredient is AI. In complex scenarios, Aegis uses AI to track and prioritize threats and assign weapons in seconds. The AI analyzes trajectory and speed, distinguishing threats from non-threats. It evaluates threats and assigns weapons, ensuring efficient defense. From detection to interception, the AI guides missiles, increasing kill probability. The AI's speed provides a critical shield. Aegis creates a defensive bubble essential for naval survival. AI is vital for running a warship, assisting with navigation and threat detection. An AI system can tirelessly monitor the ship's surroundings, building a real-time picture of maritime traffic. These AI systems learn typical patterns, flagging anomalies that might represent a threat, like a fast-approaching vessel. AI-powered navigation systems calculate the most fuel-efficient route. AI is also integrated with sonar systems to enhance submarine detection, classifying underwater sound signatures with accuracy. The future of naval warfare involves intelligent fleets where manned and unmanned vessels work together. Unmanned surface and underwater vessels are set to revolutionize naval operations. Controlled by AI, these robotic ships can extend a destroyer's sensor reach. They can also take on missions too dangerous for crewed vessels. Imagine a destroyer operating as the mothership for a robotic flotilla. Unmanned surface vessels could scout ahead, searching for enemy ships. Others could create an anti-submarine screen patrolling autonomously. Unmanned underwater vessels can conduct reconnaissance in dangerous waters. This human-machine team is the future of naval power. Modern navies network individual platforms to share information and coordinate actions in real time. AI enables a common operational picture, where every ship and aircraft sees the same battlespace map. An F-35 can transmit radar data to the fleet. AI systems like Cooperative Engagement Capability (CEC) fuse data from various sensors. Any ship can then launch a missile using this fused data even without seeing the target. This AI-driven networking distributes combat power, making the fleet more resilient. The AI manages information flow, ensuring an accurate operational picture for all commanders. The fleet acts as a single, distributed entity, greater than its parts. A destroyer's combat effectiveness depends on its ability to sustain itself and survive damage. Artificial intelligence plays a critical role in logistics and damage control. Modern warships use thousands of sensors to monitor machinery health, feeding data to AI-powered maintenance systems. This system uses predictive analytics to anticipate equipment failure, enabling proactive maintenance. In battle, AI assists with damage control, processing sensor data to display damage extent and recommend actions. By automating information flow and providing recommendations, AI helps crews make critical decisions, potentially saving the ship. AI makes the modern destroyer tougher and more resilient. Welcome back. We've soared with AI-enhanced fighters and sailed with intelligent destroyers. Now, we plunge into the silent world of the submarine. Stealth and secrecy define the submarine. Its mission, to operate undetected, gathering intelligence, controlling sea lanes, or delivering a decisive strike. Submariners rely on stealth, using the ocean's pressure and darkness to their advantage. Their survival depends on hearing without being heard. AI is transforming the silent service, providing tools to master the acoustic environment. AI algorithms process vast sonar data in real time, detecting faint signals imperceptible to humans. AI is becoming the submarine's ultimate silent partner, enhancing stealth and senses. The sonarman's role is critical. They listen to the ocean, deciphering contacts using advanced hydrophones, including bow and towed arrays. Their job is to detect faint noises from enemy warships. AI now augments these skills, acting as a tireless sonarman, trained on vast acoustic data libraries. The AI learns to recognize subtle signatures and classify contacts faster than humans. AI isolates signals, enabling focus on behavior and providing a tactical advantage. This empowers the human sonarman, handling noise and enabling higher-level analysis for the commander. For a submarine, stealth is survival. Traditionally, achieving stealth has been a passive affair, focused on making the submarine as quiet as possible. This involves meticulous engineering, from mounting machinery on sound-isolating rafts to designing special propellers that create minimal cavitation, those noisy bubbles formed by a spinning blade. Modern submarines are engineering marvels, quieter than the background noise of the ocean itself. However, adversaries are constantly developing more sensitive sonar systems to find them. This has led to the development of a new revolutionary concept: active stealth, a sort of acoustic invisibility cloak powered by artificial intelligence. The principle behind active stealth, often called active noise cancellation, is conceptually simple but technologically incredibly complex. The submarine uses its own hydrophones to listen to the noise it is making. An AI system then analyzes this noise signature in real time. In a fraction of a second, the AI calculates the exact inverse sound wave, a perfect anti-noise signal. This anti-noise is then broadcast out into the water by a series of transducers on the submarine's hull. When the original noise wave from the submarine's machinery meets the AI-generated anti-noise wave, they cancel each other out, creating a bubble of profound silence around the submarine. The role of AI in this process is absolutely critical. The submarine's own noise is not a constant, simple hum, it is a complex, dynamic, and constantly changing acoustic signature. The sound changes as the submarine speeds up or slows down, as different systems turn on and off, and as it maneuvers. A pre-programmed system could never keep up. The AI must be able to adapt instantly, continuously analyzing the noise output and generating a perfect, phase-inverted counter-signal millisecond by millisecond. It is a constant, high-speed computational challenge that only a powerful AI can manage effectively, ensuring the acoustic cloak remains intact across all operating conditions. This technology represents a paradigm shift in underwater stealth. It moves beyond simply being quiet to actively erasing one's own acoustic presence. While still a developing technology, its potential is immense. It could make a submarine virtually undetectable by passive sonar, forcing an adversary to use active sonar, sending out a ping and listening for the echo. However, using active sonar is like shouting in a dark room. It immediately gives away the pinger's own position. By making passive detection nearly impossible, AI-driven active stealth forces the enemy into a tactical dilemma, dramatically increasing the submarine's survivability and operational freedom in contested waters. The future of undersea warfare will not be fought by crewed submarines alone. A new class of vessel is emerging from the shadows, the extra-large, unmanned underwater vehicle, or XLUUV. These are not small, torpedo-sized drones, but fully-fledged robotic submarines, some over 25 meters long, capable of operating autonomously for months at a time over thousands of kilometers. Platforms like the US Navy's Orca and Australia's own Ghost Shark program are at the forefront of this revolution. These XLUUVs are designed to be the loyal wingmen of the deep, working in concert with crewed submarines to extend the reach and capability of the underwater fleet without putting sailors in harm's way. The brain of these autonomous hunters is, of course, a highly advanced artificial intelligence. The AI is responsible for every aspect of the XLUUV's operation. When a crewed submarine gives the XLUUV a mission, such as patrol this designated area and report any contacts, the AI takes over completely. It handles the complex tasks of navigation, plotting a safe course around underwater obstacles and through varying currents. It manages the vehicle's power systems, optimizing energy consumption to maximize its endurance on a long-duration mission. Most importantly, it controls the sensor payloads, autonomously searching for, detecting, and classifying potential targets using its own onboard sonar systems. The missions these AI-driven platforms can undertake are transformative for undersea warfare. An XLUV can be sent on the dull, dirty, and dangerous tasks that are ill-suited for a billion-dollar crewed submarine. It could be tasked with covertly deploying sea mines in a hostile harbor, a mission of extreme risk. It could be sent to lie silently on the seabed for weeks in a strategic choke point, acting as a remote, passive sensor, only activating to send a report when it detects a high-value enemy vessel. It could also perform long-term intelligence, surveillance, and reconnaissance missions, mapping the seabed or monitoring undersea data cables, freeing up the crewed submarine for more direct action. This human-machine teaming between crewed submarines and AI-piloted XLUUVs creates a distributed, resilient, and far more lethal underwater force. A single commander on a Virginia-class or future SSN-AUKUS submarine could potentially coordinate the actions of several XLUUVs, using them as forward scouts, decoys, or even remote weapons platforms. This multiplies their tactical presence, allowing them to control a much larger area of the ocean. The rise of the autonomous XLUUV, powered by sophisticated AI, represents one of the most significant shifts in submarine warfare since the advent of nuclear power, creating a future where the silent service has more eyes, ears, and teeth than ever before. Navigating a submarine is a uniquely difficult challenge. Unlike a surface ship or an aircraft, a submerged submarine cannot use the global positioning system since, well, the satellite signals just can't penetrate the water. For decades, submarines have relied on a technology called inertial navigation systems. These systems use a complex arrangement of gyroscopes and accelerometers to track every turn, dive, and change in speed, constantly calculating the submarine's position relative to its last known starting point. While remarkably accurate, these systems accumulate small errors over time, a phenomenon known as drift, which can lead to significant positional uncertainty on a long, clandestine mission. Artificial intelligence is now being used to create far more accurate and reliable navigation systems, reducing this dangerous drift. One of the most promising techniques is called terrain-aided navigation. This system uses the submarine's high-resolution sonar to create a detailed real-time map of the seabed directly beneath it. An AI algorithm then compares this live sonar map to a pre-loaded, highly detailed digital chart of the ocean floor, much like a person matching a small piece of a map to a larger one. By finding a perfect match between what its sonar sees and the master chart, the AI can determine the submarine's precise position with incredible accuracy, effectively resetting the drift from the inertial navigation system without ever needing to surface. The computational power of AI is essential for this process. The ocean floor is not always a unique landscape of mountains and canyons. It can often be a vast, featureless plain. The AI must be able to analyze subtle topographical features and find a unique match from a massive database of bathymetric charts, all while the submarine is moving. This allows the submarine to remain submerged and undetected for much longer periods, confident in its exact position. This is critically important for missions that require pinpoint precision, such as deploying special forces, tapping undersea cables, or navigating through narrow, hazardous underwater passages without being detected by enemy sensors. Furthermore, AI can assist in route planning for these clandestine missions. The AI can analyze all available data, ocean currents, water temperature layers that can block sonar, known enemy sensor locations, and seabed topography, to calculate the safest and most stealthy route to a target area. It can plot a course that takes advantage of natural acoustic shadows and avoids areas where the submarine is more likely to be detected. This AI-powered navigator acts as an expert assistant to the submarine's human navigation team, providing them with data-driven recommendations that enhance the stealth and safety of the mission, ensuring the silent service can get where it needs to go without ever being compromised. Section 6. The Underwater Chessmaster. AI in Tactical Decision-Making. The commander of a submarine is, well, the ultimate underwater chessmaster. They must constantly think several moves ahead, always anticipating the enemy's actions while managing their own vessel's position, stealth, and sensor status. This decision-making process happens in a complex three-dimensional environment with incomplete information, and all under immense pressure. Just a single tactical error can lead to detection and destruction. Artificial intelligence is now being developed to act as a powerful tactical aid. A digital co-commander that can analyze the tactical situation and provide data-driven insights, helping commanders make the best decisions in the heat of the moment. This AI system, often called a combat management system, fuses all the information available to the submarine. It takes data from sonar suites, electronic intelligence receivers, and intelligence reports via secure data links. The AI then constructs a comprehensive model of the battle space, tracking the position, course, speed, and likely identity of every contact. It doesn't just show where contacts are now, it uses predictive algorithms to show where they're likely to be in the next 5, 10, or even 30 minutes, a function known as track prediction. This allows the commander to see how the tactical picture is evolving over time. The AI's most valuable contribution is its ability to run rapid-fire simulations. When a tactical problem arises, for example approaching an enemy warship without detection, the commander can use the AI to wargame different courses of action. The AI can simulate thousands of scenarios in seconds. What happens if we speed up? What if we dive deeper? What's the probability of detection if we take this route versus that route? The AI presents simulation outcomes to the commander, often as ranked options with probabilities of success and risk. It might recommend a specific course that offers the best balance of stealth and tactical advantage. This does not remove the human from command. The AI is a recommendation engine, not the final authority. The commander retains full control, using their experience, intuition, and strategic understanding to make the final call. The AI provides quantitative analysis, freeing up the commander's mental bandwidth to focus on qualitative decision aspects. It provides a powerful check against human cognitive biases and stress-induced errors. By serving as an unerringly logical tactical advisor, AI helps the underwater chessmaster see the board more clearly, anticipate opponent moves more accurately, and ultimately win the silent and deadly game being played in the dark depths of the ocean. Welcome back. We have journeyed through the skies with intelligent fighters, sailed the waves with smart destroyers, and plumbed the depths with perceptive submarines. Now, we arrive at the undisputed monarch of the high seas, the ultimate symbol of naval power and global reach, the aircraft carrier. These are not merely ships, they are mobile, sovereign territories, floating airbases capable of projecting a nation's power across thousands of kilometers of ocean. A modern nuclear-powered carrier like the American Nimitz or Ford class is a true city at sea, home to over 5,000 sailors and aviators, and an air wing of up to 90 advanced aircraft. Its purpose is simple: to control the sea and the sky wherever it sails. The sheer scale and complexity of carrier operations are honestly mind-boggling. An aircraft carrier is arguably the most complex machine ever created by humankind. It's a nuclear power plant, an airport, a hotel, a hospital, and a fortress, all combined into one mobile platform. The core mission is to launch and recover high-performance aircraft from a short, moving, and often pitching flight deck. A task that's been described as one of the most dangerous and demanding activities in the world. Managing this ballet of the deck, coordinating the movements of dozens of aircraft, hundreds of personnel, and countless tons of fuel and munitions, all while the ship is underway, is a logistical and operational challenge of the highest order. This is where artificial intelligence is becoming the indispensable central nervous system of the modern carrier. Given the immense complexity, the sheer volume of data, and the split-second timing required, relying on human coordination alone is no longer sufficient to operate at peak efficiency and safety. AI is being woven into every facet of carrier operations, from managing the chaotic flight deck and planning complex missions, to defending the ship from attack and managing the vast logistical needs of its crew and air wing. It acts as a force multiplier, augmenting the skills of the human crew and allowing them to manage a level of complexity that would have been impossible just a generation ago. In this act, we will step aboard these floating giants to explore how AI is transforming their operations. We'll see how it helps orchestrate the dangerous dance of flight operations, how it acts as a digital quarterback for the entire carrier strike group's missions, and how it's enabling the integration of a new generation of unmanned drones into the carrier air wing. We'll also examine its crucial role in defending this high-value asset and in keeping the floating city running smoothly. The aircraft carrier remains the queen of the seas, and AI is the invisible crown that ensures her continued reign in the 21st century. The flight deck is one of the most dangerous and intensely choreographed workplaces on Earth. The air boss oversees the deck, but AI is becoming a powerful assistant, optimizing the flow of operations. These AI systems create a real-time digital twin of the flight deck, analyzing data to plan efficient movements. This optimization increases the sortie generation rate, a key measure of combat effectiveness. AI is integrated into launch and recovery systems like emails and AAG. The AI calculates the force needed for each launch and adjusts the arresting gear for safe deceleration. This reduces stress, increases safety, and demonstrates AI taking on critical tasks. An aircraft carrier does not fight alone. It is the centerpiece of a carrier strike group, a powerful formation that includes destroyers, cruisers, submarines, and supply ships. The carrier's air wing is the primary offensive weapon tasked with striking targets deep inland to maintaining air superiority over the fleet. Planning and executing these missions is incredibly complex, requiring coordination of dozens of aircraft and integration of intelligence from the entire strike group. Artificial intelligence is now acting as the digital quarterback for the carrier strike group, helping commanders plan and control missions with unprecedented speed and precision. Modern mission planning systems use AI to analyze a vast array of data. The AI considers mission objectives, known enemy defenses like radars, surface-to-air missiles, enemy fighters, the weather aircraft status, and weapons on board. It can then run thousands of simulations to determine the optimal plan of attack. It might recommend the best route to avoid radar detection, suggest the ideal combination of aircraft, and calculate precise timing for each phase to ensure perfect synchronization. This creates more effective mission plans in a fraction of the time. Once the mission is underway, AI shifts to real-time monitoring and control, providing strike leaders with a clear operational picture, tracking progress of every aircraft. If something unexpected happens like a new threat or maintenance issue, the AI can instantly reassess the situation rapidly, calculating a new plan on the fly, suggesting how to reroute aircraft or reassign targets to ensure mission success. This real-time adaptation to dynamic battlefields is a crucial AI advantage. AI-powered command and control extends to the entire strike group. The carrier acts as the central hub, fusing intelligence from escort ships and aircraft to build the complete battlespace picture. This shared awareness enables unprecedented collaboration. For example, an E-2D Hawkeye early warning aircraft might detect an incoming missile threat. Its data feeds into the carrier's AI system, which cues a destroyer to engage with Aegis. The AI quarterback ensures every player knows the plan and can react in unison to any threat. For decades, the carrier air wing has been composed entirely of manned aircraft. That era is now coming to an end. The future of carrier aviation involves a mixed force of manned fighters and a new generation of unmanned aerial vehicles operating seamlessly from the flight deck. The first major step in this direction is the MQ-25 Stingray, an unmanned aerial refueling tanker. This AI-piloted drone is designed to take over the vital but repetitive task of in-flight refueling, a mission currently performed by manned FA-18 Super Hornets. This seemingly simple change has revolutionary implications for the carrier's combat power, all made possible by artificial intelligence. The AI is the heart of the MQ-25's autonomous capability. When the drone launches from the carrier, its AI pilot handles all aspects of the flight. It navigates to a pre-assigned refueling track, maintains a stable orbit, and communicates with the manned fighters that need fuel. When a fighter approaches, the AI uses its sensors to safely guide the refueling probe and transfer the fuel, a delicate maneuver that requires incredible precision. This level of autonomy, enabled by AI, means that no human pilot is needed to fly the aircraft, either from the ground or a control station. It operates as a true robotic teammate within the air wing, taking commands from the mission controllers on the carrier. By offloading the tanking mission to AI-driven drones, the carrier's most capable combat aircraft, the Super Hornets and F-35S, are freed up for their primary strike and fighter roles. Currently, a significant portion of a carrier's fighter fleet is used as tankers, reducing the number of aircraft available for combat missions. The MQ-25 effectively adds more shooters back into the lineup without increasing the total number of aircraft on board. This dramatically increases the carrier's offensive punch and extends the range of its strike packages, as manned fighters can now launch with a full weapons load and top up with fuel from the drones once airborne, allowing them to fly further and hit targets deeper in enemy territory. The MQ-25 is just the beginning. It is paving the way for a future where a wide range of AI-piloted drones will operate from the carrier deck. Future unmanned systems could be used for intelligence, surveillance and reconnaissance, electronic warfare, or even as loyal wingman-style combat drones, flying alongside manned fighters. The AI systems being developed for the Stingray to handle autonomous carrier launch, recovery and deck operations are the critical building blocks for this future unmanned carrier air wing. AI is the key that will unlock the potential of human-machine teaming at sea, fundamentally reshaping the composition and capability of carrier aviation for decades to come. An aircraft carrier is the most valuable single asset in any navy, a billion-dollar platform carrying thousands of souls. As such, its protection is the highest priority for the entire carrier strike group. The carrier itself is the last line of defense, equipped with its own powerful array of sensors and close-in weapon systems designed to defeat any threat that gets past its destroyer and cruiser escorts. In an age of hypersonic missiles, stealthy drones and potential swarm attacks, defending the carrier requires a level of vigilance and reaction speed that is beyond human capability. Artificial intelligence is therefore becoming the carrier's all-seeing sentry, the digital guardian that never blinks. The carrier's defensive systems, like the CRAM and Phalanx close-in weapon system, are heavily reliant on AI to function effectively. These are automated detect-to-engage systems. Their integrated radar and thermal sensors constantly scan the sky around the ship. An AI algorithm analyzes this sensor feed, searching for the signature of an incoming threat, like a sea-skimming anti-ship missile. When the AI detects and classifies a target as hostile, it can autonomously track it, calculate a firing solution, and, if authorized by the human operators, command the weapon system to open fire with a torrent of cannon shells or a volley of short-range missiles to destroy the threat just seconds before impact. The greatest emerging threat to carriers is the swarm, a large-scale coordinated attack by dozens or even hundreds of small, cheap and intelligent drones. A human crew would be completely overwhelmed trying to track and engage so many individual targets simultaneously. This is a problem tailor-made for AI. Advanced defensive systems use AI to analyze the swarm as a whole, identify the most immediate threats within it, and efficiently allocate the ship's defensive weapons to counter them. The AI can prioritize targets, assigning missiles to the drones that pose the greatest danger while tasking directed energy weapons, like lasers, to handle others, all in a coordinated and instantaneous fashion. This AI-powered defense extends beyond just shooting down missiles. It is also crucial for electronic warfare and decoy deployment. When the carrier detects it is being targeted by an enemy radar, an AI system can instantly analyze the incoming signal and choose the best countermeasure. It might decide to use powerful jamming signals to blind the enemy radar, or it could deploy a Nulka hovering rocket decoy, which is designed to fly away from the ship and seduce the incoming missile by mimicking the carrier's radar signature. The AI makes this tactical choice in a split second, providing a multi-layered intelligent defense that combines physical interception with electronic deception to ensure the carrier's survival in the most hostile environments. Operating an aircraft carrier is as much a logistical challenge as it is a military one. It's a floating city that must be able to sustain itself for months on end, far from any port. This involves managing an immense and complex supply chain, storing and distributing millions of liters of jet fuel, thousands of tons of munitions, and vast quantities of food and spare parts for its crew of 5,090 aircraft. Keeping this city running at peak efficiency requires a level of planning and foresight that is, honestly, perfectly suited to artificial intelligence. AI is becoming the smart city manager for the carrier, optimizing its logistics and maintenance to ensure it can stay on station and ready for the fight. Much like the systems we've seen on destroyers and fighters, carriers are equipped with advanced, AI-driven condition-based maintenance systems. Thousands of sensors monitor the health of the ship's critical systems, from its nuclear reactors and steam catapults to its elevators and electrical grids. And AI analyzes this constant stream of data, using predictive analytics to identify components that are showing signs of wear and are likely to fail. It can then automatically generate a work order for the ship's maintenance crews, and even check the ship's inventory to see if the required spare part is on board. This proactive approach prevents unexpected breakdowns, increases the reliability of the ship's vital equipment, and ensures the carrier remains fully operational. This intelligence extends to managing the carrier's vast stores. An AI-powered logistics system can track the consumption rates of everything from jet fuel and missiles to fresh vegetables. By analyzing operational plans and historical data, the AI can predict future demand with great accuracy. This allows the ship's supply officers to know exactly what they need and when they need it, making underway replenishment operations, the complex process of transferring supplies from a support ship while at sea, far more efficient. The AI can generate a precise resupply request, ensuring that no space is wasted on unneeded items and that the carrier always has what it needs to sustain its mission. Ultimately, this smart logistics network ensures the carrier's endurance and self-sufficiency. By optimizing the use of resources, predicting maintenance needs, and streamlining the supply chain, AI helps to maximize the carrier's time on station and its overall readiness. It reduces the workload on the human crew, automating routine logistical calculations, and allowing them to focus on their core duties. From the flight deck to the deepest engineering spaces, AI is working silently in the background, not just as a weapon system, but as the intelligent backbone that keeps the entire floating city functioning as a cohesive and powerful instrument of national will. Welcome back. AI is revolutionizing warfare, acting as a digital co-pilot. The future lies in connecting these intelligent platforms, sharing their brains. This is Joint All-Domain Command and Control, or JDC2. AI is key to this ambitious undertaking, breaking down barriers between military branches to create a unified combat cloud. AI algorithms will correlate data, identify threats, and maintain a god's-eye view of the battlefield. JDC2 creates a force more lethal and adaptable, where the whole is more powerful than its parts. JDC2 is the future and AI is the architect. A tactically disruptive concept for future AI warfare is the rise of the autonomous swarm. Swarm warfare leverages the power of immense numbers of small, cheap, and expendable autonomous drones. They work together cooperatively like a colony of insects to overwhelm an enemy's defenses. The AI is the hive mind, giving high-level commands to the swarm. The AI coordinates the actions of drones to achieve the goal. If one drone is shot down, the AI instantly reallocates its task, making the collective incredibly resilient. The tactical implications are profound and pretty terrifying for a conventional military force. It's a new form of combat power that will force every military to rethink the very nature of defense. For decades, military theorists have talked about the OODA loop: observe, orient, decide, and act. In the coming era of AI warfare, this loop will be compressed down to microseconds. The future of conflict will be defined by the speed of relevance. AI can observe the battle space with thousands of sensors simultaneously. In situations such as defending against a hypersonic missile, the decision to act must be delegated to the machine. An adversary who has fully embraced AI will be able to process information and make decisions at a tempo impossible for a human-centric force to counter. It will be a software arms race to develop superior algorithms. As we enter this new era of AI warfare, we must confront the issue of ethics and human control. Leading military powers are committed to the principle of human command. AI can augment decision-making, but the authority to employ lethal force must remain with a human. However, the speed of future warfare may demand reaction times too fast for human intervention. The solution lies in designing systems where humans set rules of engagement beforehand. The human moves to exercising meaningful control through design, testing, and supervision. The future of AI warfare will be defined by the wisdom with which we choose to employ these systems. We have traveled on an incredible journey through the heart of the modern military, witnessing a revolution unfolding in the silent processing of a microchip. We started our exploration high in the sky, discovering how artificial intelligence is transforming the stealth fighter into a flying brain. From the skies we moved to the vastness of the ocean, boarding the modern destroyer. We then dove deep beneath the waves into the clandestine world of the submarine. Finally, we stepped onto the deck of the aircraft carrier, the floating city and queen of the seas. AI ensures these behemoths remain the ultimate symbols of global power projection. The impact of AI is profound, but we are truly only at the beginning. The next frontier is the full integration of smart platforms into a single network. This combat cloud promises a military that can act with unity and speed. This progress pushes us into uncharted territory and some deeply challenging questions. The central question is that of meaningful human control. The specter of fully autonomous weapons is a line that many are rightly hesitant to cross. Striking the right balance between AI speed and human command is the single greatest challenge. How we navigate this will define conflict for generations. Our journey through military AI has shown us a fundamental reshaping of power and conflict. From the F-35's digital co-pilot to networked forces and swarm warfare, this revolution is a deeply human story. Understanding these developments is vital. Decisions made today will shape our world's security. As citizens, we must be informed about these capabilities and the ethical questions they raise. Our mission is to demystify these topics and create space for thoughtful discussion. Subscribe to join our community and support in-depth educational content. Thank you for joining this exploration. I look forward to our next adventure.